Hello, students. So, today we start a new chapter, that is chemical bonding and molecular structure. This chapter is very important to know different type of bonds as well as different structural arrangement of a chemical compound. In this chapter, we discuss about different type of bond and different condition to form a chemical bond, as well as lattice energy, solvation energy, and we also discuss about Lewis dot model of a chemical compounds, and the main important part of this chapter, that is VSEPR theory, valence bond theory, and molecular orbital theory. Actually, this theory used for determination of different structure, and the latest theory is molecular orbital theory. And later we discuss about the dipole moment of different type of structure, as well as resonating structure and hydrogen bond, and also the bond angle of different compound. you know every system in this universe has a tendency to acquire a state of minimum energy. Minimum energy means when a molecule acquires minimum energy, then these molecules or atoms or ion are more stable. So higher energy means less stable, and minimum energy means more stable. Since isolated atom generally have higher energy, for example A, it is an isolated atom or ion. So when these atoms or ions form bond, that is A bond B, then it is a molecule. So isolated atom have a natural tendency to form aggregates. Here A aggregates with B, which have a lower energy than individual atom. A has a higher energy, and after aggregation or after forming a molecule, the energy of the A atom decreases. Therefore, the energy of a molecule always lower than the energy of an atom. In the formation of aggregates, the extent of lowering of energy varies from system to system, but generally, if the lowering exceeds 40 kilojoule per mole of atom, we can say the chemical bonds are formed. So, the chemical bond may be defined as the force which holds atoms or ion together. For example, A and B, it's atom, it's atom. So actually chemical bonds means they present an attraction force. Sometimes this attraction force created by sharing of electrons, and sometimes this attraction force may be created by donation of electrons. So the phenomenon of union of two or more atoms involving redistribution of electrons, so that each atom involved in bonding and acquires stable configuration in order to gain stability is known as chemical bonding. Simply, we can say chemical bonding means just attraction of two isolated atoms. Generally, there present three type of bond, that is ionic bond, covalent bond, and coordinated bond. These all bonds are formed either by sharing of electrons or by donation of electrons. So one by one we discuss about this type of bond. So first one is ionic bond. Actually, ionic bond formed by the complete transformation of an electron or electrons from one atom to another atom is known as electrovalent or ionic bond. For example, sodium. You know, sodium have 11 electron, that is 1s2, 2s2, 2p6 and 3s1. This s electron is known as valence electron, and this orbit, that is third orbit, is known as valence shell, and 3s is known as valence orbital. You know, as sodium have 11 electron, but every atom actually try to arrange themselves similar like a noble gas or nearest noble gas. So the nearest noble gas of sodium atom is neon, which have 10 electron, that means 1s2, 2s2, 2p6, and neon have stable electronic configuration. So always sodium try to arrange themselves similar like neon. Another atom is chlorine. You know, chlorine have 17 electron. That means the electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2 and 3p5. That means they are present 5 electron in their valence orbital. And the nearest noble gas of the chlorine atom is argon, which have 18 electron, that is 1 electron more than chlorine. Here chlorine required 1 electron to acquire the octet electronic configuration like argon, and also sodium have to remove 1 electron to acquire this stable electronic configuration. So when sodium react with chlorine, then sodium produce sodium plus because it is the stable cation, and also chlorine produce Cl minus anion because it is also a stable anion. So when sodium reacts with chlorine, ion with opposite electronic charge are formed during the chemical reaction, and after this it produces NaCl, and in this compound actually sodium present as Na plus and chlorine present as Cl minus. This oppositely charged ion are held together by a Coulombic force. That means we can say sodium have 1 valence electron to their valence shell and chlorine have 7 electron to their valence shell. So when sodium react with chlorine, this 1 valence electron, actually sodium, donates to the chlorine atom, and sodium transfer into sodium plus, and after accepting an electron, chlorine transfer into Cl minus. So it's a cation and it's a anion. So in between this cation and anion, there present a Coulombic attraction force. Coulombic attraction force. and this Coulombic attraction force actually depends on the charge of atoms as well as distance of the atom. And the system will be at a lower potential energy when the two oppositely charged ions are close to each other than when they are far apart. So actually, this attraction force considered as ionic bond. So ionic bond means the attraction between two oppositely charged anions. Similar case arise in case of calcium oxide also. You know, calcium have 20 electron, that is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. If this calcium atom remove this 2 electron from their valence shell, then calcium acquire stable electronic configuration like argon. Similarly, oxygen, which have 8 electron, and the electronic configuration of oxygen is 1s2, 2s2, 2p4. That means oxygen required 2 electron to acquire the stable electronic configuration like neon. So calcium, which have 2 electron in their valence shell, donates this electron to the oxygen atom. Therefore, calcium transfer into calcium 2 plus and oxygen transfer into oxygen 2 minus. It is a cation and oxygen which is a anion. And in between calcium 2 plus and oxygen 2 minus, there present a attraction force, that is Coulombic attraction force, and this attraction force actually known as ionic bond. And this calcium oxide known as ionic compound because a ionic bond present in between calcium 2 plus and oxygen 2 minus. So this is ionic bond. So in simply we can say ionic bond means just attraction between cation and anion. In periodic table, the group 1 and group 2 elements, that is alkaline metal and alkaline earth metal, which have lower ionization energy because they easily remove their valence electron. Similarly, from group 15 to group 17, actually these elements required electrons to acquire stable electronic configuration. So this group 1 and group 2 metals generally react with this group 15 to group 16 non-metals and form a ionic compound. For example, lithium react with chlorine to produce lithium chloride. Chlorine is a group 17 element. Similarly, sodium react with oxygen. Oxygen is a group 16 element to produce sodium oxide. Simply, calcium react with chlorine to produce calcium chloride. Similarly, magnesium react with nitrogen to produce magnesium nitrate, like this. So generally group 1 and group 2 metals react with non-metals, that is from group 15 to group 17, to produce a ionic compound, and in this ionic compound there present a ionic bond. So what are the conditions for the formation of ionic bond? First one is valence electron. You know, the group 1 and group 2 metals generally react with the non-metals. So, if the valence electron of a metals present 1, 2 or 3, for non-metals, if the valence electron present 5, 6 and 7, then these metals and non-metals easily react with each other. For metals, it required 1, 2 or 3 valence electron, that is group 1, group 2 and group 3. Because in group 1, all metals present 1 valence electron to their valence shell. For group 2, they are present 2 valence electron in their valence shell, and for group 3, that is aluminium, they are present 3 electron in their valence shell. So when metals contain 1, 2 or 3 valence electron, they can easily react with non-metals which contain 5, 6 or 7 valence electron. For group 15 series, they present 5 valence electron to their valence shell, and for 16 series, they present 6 electron to their valence shell, and for 17 elements, they present 7 electron to their valence shell. So the first point is valence electron. Next one is electronegativity. For example, A and B form a ionic bond. If the difference between electronegativity between this A and B atom is more, then the ionic bond are more stable. So more difference between electronegativity, more stable ionic bond formation. So this is the second point. Third point is ionization energy. You know, ionization energy means the energy required to remove an electron from their valence shell. So for metals, they required less ionization energy because metals always stable in positive oxidation state. So they can easily remove electron. If the ionization energy of a metal is high, that means they require more energy to remove an electron. So it cannot easily form a cation. So if metal have lower ionization energy, then it can easily produce a stable ionic compound. And last one is lattice energy. What is the lattice energy? You know, ionic bond means the attraction between a cation and an anion, and this attraction actually called Coulombic attraction force, and Coulombic attraction force actually proportional with Q1 and Q2. That is, Q1 and Q2 means charge of the ion. If charge of the ion increase, then the attraction force increase, therefore the lattice energy increase. Then the element or the ionic compound which have more Coulombic attraction force are more stable. Similarly, we can say the cation or anion which have more charge, then it form stable ionic compound. Ionic compounds have high melting points because the electrostatic force of attraction, that is ionic bond between cations and anions, is strong. It takes a lot of energy to overcome this attraction in order to allow the ions to move from freely and from a liquid. So there are so many factors that affects on this melting point. So first one is charge of ion. As you know, the greater the charge, the greater the electrostatic attraction. That means charge directly proportional with electrostatic attraction force. So the greater the charge, the greater the electrostatic attraction force, that is the attraction between cation and anion. And if the electrostatic attraction force or Coulombic attraction force increase between a cation and anion, then they required more energy for melting of this ionic compound. For example, the melting point of sodium chloride is 801 degrees centigrade, and here sodium chloride present as sodium plus and Cl minus. So they are present one positive and one negative charge. If you notice, for magnesium oxide, then the melting point is 2800 degree centigrade. Why? Because here magnesium present as Mg2 plus and oxygen 2 minus. So in case of sodium chloride, they present as uni positive and uni negative ions, and in case of magnesium oxide, they present as di-positive and di-negative ion. So consequently, the attraction between magnesium cation and oxygen anion is more than sodium chloride. So they required more energy to melt them. So sodium chloride have lower melting point than magnesium oxide. Second factor is size of atom. Similar ion can pack closer together than larger ion, so the electrostatic attraction is greater. So smaller ion can pack closer together, and larger ion next factor is size of atom. Generally, smaller ion can pack closer together than larger ion. If you consider two smaller ion, then there present more attraction force than larger ions. So if the cation and anion have smaller size, then there present strong attraction force compared to large cation and large anion. So the ionic bond for smaller cation and anion is stronger compared to large cation and large anion. And the melting point of the smaller cation and smaller anion also greater than larger cation and anion. For example, sodium fluoride, potassium fluoride, rubidium fluoride and cesium fluoride. If we move from top to bottom in a periodic table, the size of the element increase. So here sodium have smaller size than potassium, then rubidium, then cesium. So if it is sodium and it is fluorine, then in case of potassium, the size of the potassium actually greater than size of the sodium. So the attraction between sodium and fluorine is stronger than potassium and fluorine. In case of cesium fluoride, the size of the cesium is more larger than the size of fluorine. So there present less attraction force between cesium and fluorine. So the melting point order of this following compound is: sodium fluoride have higher melting point than potassium fluoride, potassium fluoride have higher melting point than rubidium fluoride, and rubidium fluoride have higher melting point than cesium fluoride. So the actual melting point of sodium fluoride is 1270 degrees centigrade. For potassium fluoride it is 850 degrees centigrade. For rubidium fluoride it is 775 degrees centigrade, and for cesium fluoride, the cesium fluoride, the melting point is 683 degrees centigrade. Then you can easily notice that if you move from top to bottom, then size of the cation actually increase, as well as the attraction force between cation and anion decrease, and melting point also decrease. So we can say if size increase, then melting point decrease. So size is inversely related with melting point. Similarly, if we notice for sodium fluoride and sodium iodide, then here the size of the anion, it is different. Fluorine have smaller size than iodine. So size is inversely related with melting point. So here iodine have greater size than fluorine. So sodium iodide, which have lower melting point than sodium fluoride, because it is inversely related. And actually the melting point of sodium fluoride is 1270 degrees centigrade, and for sodium iodide it is 925 degrees centigrade. Next point is hardness. Ionic compounds are hard and brittle. The strong ionic bond between the cation and anion holds the ion in very rigid lattice. So similar ions or smaller ions can pack closer together than larger ions, and hence are hard in nature. Hardness depend upon, first one is charge, and second one is ionic radii. Here charge, if charge of the cation and anion increase, then the attraction force actually increase, then it become more hard. So charge is directly proportional with hardness. And ionic radii means size of the ions. If the size of the ions increase, then the attraction force between them decrease, as well as hardness also decrease. So ionic radii is inversely related with hardness. Third character is conductivity. In order for a substance to conduct electricity, it must contain mobile particles capable for carrying charge. Solid ionic compound do not conduct electricity because the ions or charged particles are locked into a rigid lattice. In case of solid, they very strongly attracted with each other and they have a rigid structure. So solid ionic compound cannot conduct electricity. In case of liquid or in molten state, they slightly apart from each other, and when they molted, the ions are free to move out for a lattice structure. And when the ionic solid is dissolved in water to form an aqueous solution, the ions are released from the lattice structure and are free to move. So solution conduct electricity just like the molten or liquid state. So if we say solid state which have very poor electrical conductivity, and in case of ionic liquid it also have good conductivity, and when this solid are dissolved in aqueous solution, that is in aqueous solution, the ionic compound also have good electrical conductivity. Next we discuss about covalent bond. So what is covalent bond? A type of chemical bond in which there is a mutual sharing of electron between two atoms is called covalent bond. So here we use mutual sharing. So what is mutual sharing? For example, if you notice, for H2O molecule, here present two types of atom, that is oxygen and hydrogen. In case of oxygen, you know the electronic configuration of oxygen is 1s2, 2s2, 2p4. That means they are present 4 electron in their valence shell. But oxygen required more 2 electron to gain octet electronic configuration, similar like neon, which have 10 electrons and 8 electrons in their valence shell. In case of hydrogen, you know they present only 1 electron, that is 1s1, and similar like oxygen, also hydrogen required 1 electron to gain stable electronic configuration like helium, where present 2 electron in their valence shell. So here oxygen required 1 electron, and so here oxygen required 2 electron for octet electronic configuration, and hydrogen required 1 electron for duplet electronic configuration. So what can we do? In case of oxygen, they are present 4 electron in their valence shell, and in case of oxygen they are present 6 electron in their valence shell, and hydrogen present 1 electron in their valence shell. So here hydrogen and oxygen are shared their electron between them. So if this hydrogen shared 1 electron with oxygen atom, and this hydrogen also shared one electron with oxygen atom, then oxygen present 8 electron in their valence shell. Similarly, if oxygen shared 1 electron with hydrogen, then also hydrogen present 2 electron to their valence shell. So here oxygen and hydrogen both shared their electron with each other. So this type of bond known as covalent bond, and this 4 electron actually known as lone pairs of electron. So here present 2 lone pairs, and this bond actually known as covalent bond. So in case of covalent bond, there actually occur sharing of electron. Covalent bond can be classified into 2 categories, that is single bond, double bond, and triple bond. What is single bond? If they are present only one bond between two atoms, then it is known as single bond. For example, HCl, HBr, H2O, ammonia. So in this molecule there present only one bond between two atoms. So these are known as single bond. And double bond means if there present two bond between two atoms, then it is known as double bond. For example, ethene, you know, it is ethene molecule and there present two electron. In case of oxygen, that is aerobic oxygen, there also present two bond between these two atoms. So this type of bonds known as double bond. And triple bond means if there present three bonds between two atoms, then it is known as triple bond. For example, acetylene, for example, carbon monoxide. So this type of molecules, there present three bond in between two atoms. So these are few examples of single bond, double bond and triple bond. By the help of Lewis dot model, we can easily identify the number of bonds of a molecule, that is covalent molecule. So for example, carbon dioxide. In case of carbon dioxide, you know, carbon present 4 valence electron and oxygen present 6 valence electron. So it is Lewis dot structure. So in case of oxygen, they required 2 electron for octet electronic configuration, and in case of carbon, they required 4 electron for octet electronic configuration. So this 2 electron actually carbon share with oxygen, and each oxygen share 2 electrons with carbon atom, just like this. So in case of carbon, there present 8 electron to their valence shell, and in case of oxygen also there present 8 electron to their valence shell. So it produce carbon dioxide and there present double bond. Here 2 electron means 1 bond, so as there present 4 electron, so it produce double bond. So carbon dioxide, in case of carbon dioxide, there present double bond in between carbon and oxygen. Similarly, for acetylene molecule, there present 2 carbon atom, and you know there present 4 valence electron for carbon atom, and as there present 2 carbon atom, so what will happen? Actually this carbon share their electron with hydrogen and neighboring carbon atom, and you can see there present 8 electron, that is 1 2 3 and 4 5 6 7 8. Similarly, for this carbon atom also there present 8 electron if neighboring carbon atom and hydrogen share their electron with this carbon, and also hydrogen present 2 electron to their valence shell. So the structure of ethylene like this, because they are present 6 electron, so here present triple bond between 2 carbon atom and present single bond between carbon and hydrogen. So this is the triple bond. So this type of bond formation actually occur in covalent molecule. So those molecule which form covalent bond or which form bond by sharing their electrons are known as covalent molecule. Next point is condition for covalent bond. So the first condition is valence electron. Generally, covalent bonds are formed between two non-metal. For example, A and B, there present covalent bond between them, then this A and B, both elements are non-metal in nature. For example, hydrogen and chlorine, that is hydrogen chloride. Hydrogen also a non-metal and chlorine also a non-metal, so they are present a covalent bond. Similarly, oxygen, oxygen are covalent in nature. Similarly, methane, carbon and hydrogen both are non-metal in nature. So actually, covalent bond formed between two non-metal, and if the valence electron for non-metal more than 3, then there is a chance to form a covalent bond. So valence electron play a crucial role to formation for covalent bond. So for covalent bond, the second important factor is electronegativity. Actually, for ionic bond, when the two cation and anion have greater difference between them, then they produce a stronger ionic bond. But in case of covalent bond, it is just opposite. So for covalent bond, if we consider that is A and B, then the electronegativity difference between these two elements are very small, either very small or very similar, like two atoms. So in case of covalent bond, the two atoms have very small difference in their electronegativity. So this is the second important point. And third important point, that is distance or ionic radius or size of element. So how size affect the formation of covalent bond? The size of the element if smaller, that is it is two elements, that is A and B. If the size of the element is smaller, then the distance between two nuclei also shorter. And if the distance between two nuclei are shorter, then there present more attraction force between these two elements, as well as the strength of covalent bond increase. So if size reduce, then strength of covalent bond also increase. So this is the condition for covalent bond formation. Next one is coordinate bond. So in case of coordinate bond, it is like that. If A atom have two extra electron to the valence shell, that is lone pair of electron, and if B electron stable when they accept electron, then this A atom act like a donor atom and B atom act like a acceptor atom. And if A atom donates its electron to the B atom, then they produce a bond just like this. Here this arrow means A atom donate electron to the B atom. So this type of bond known as coordinate bond. And for coordinate bond, two conditions have to be maintained, that is, in case of donor atom, there must be present extra electron, and for accept electron, the acceptor atom must have vacant orbital, either it vacant p or vacant d, because actually donation occur between this lone pairs or negative charge electron to the vacant p or d electron. So this type of bond known as coordinate bond. For example, ammonia. This is ammonia molecule, and in case of ammonia there present one lone pair of electron, and if you notice that when H plus ion react with ammonia, then this lone pair of electron donate to the H plus ion and it produce ammonium ion like this. So here produce a coordinate bond between nitrogen and ammonia, and as nitrogen act as a donor atom and donate their electron, so there present a positive charge in nitrogen atom, So this molecule known as coordinated molecule. Similarly, in case of water molecule, also they are present two lone pair on oxygen atom, and when water molecule react with H plus ion, then again the lone pair of oxygen donate to the hydrogen H plus ion and it produce H3O plus, and the structure of H3O plus like that is oxygen atom and one coordinate bond present between oxygen and hydrogen atom, and there present two hydrogen which is covalently bonded with oxygen. So this bond actually known as coordinate bond, and there present positive charge on oxygen atom. Similar BF3 molecule, in case of BF3 there present vacant p orbital. So when BF3 molecule contact with some electron denser molecule, then it may accept electron from this negative charge or lone pair of electron, and again they produce a coordinate bond. So this type of bond known as coordination bond. I think you can now understand the ionic bond as well as covalent bond and coordinate bond. Okay, thank you.